Welcome to hear the second lecture on air quality. This time we are going to discuss about road traffic emission calculations. During this lecture I will show you some basic ideas behind the estimating the nitrogen oxide and particulate matter emissions caused by road traffic. I will present the calculation method and what kind of data we need to get started with the emission calculations. In the end of the lecture, I will show you a couple of examples. The European Environmental Agency has published an emission inventory guidebook, and it includes a chapter called Exhaust Emissions from Road Transport, and that is also our backbone here. The guidebook describes 3 different types of methods to calculate the emissions: Tier 1, 2 and 3. Which ones should we choose then? The answer depends on the available input data. While Tier 3 method needs the most accurate information, Tier 1 is a rough estimate with less information from the road and the country. In Finland, we usually choose the Tier 3 method since we have quite much data available, and luckily it's openly available as well. The emission parameters in the Tier 3 method depends on 4 things: the type of vehicle, so that means is it a passenger car, light commercial vehicle, bus, trucks without a trailer or with a trailer, and the fuel type the vehicles use, that means the petrol, diesel, gas and so on, and on the environmental class of the vehicles. I mean by environmental class the Euro class. And the driving speed of the vehicles. I've sketched the emission calculation method in 4 steps. The step 1, we first collect the emission parameters from the EEA EMEP guidebook. And this is done for every vehicle category and subcategories on fuel type and on Euro class, and for every driving velocity necessary, since the emission parameters depend on all these 4 things. In step 2, we look at the performances of each subcategory type in fuel and Euro classes and how they are distributed, and combine this information of performance with the emission parameters. In step 3, we look how much there are vehicles in each category in each road segment we want to study, and combine this information to the emission parameters and performance information from step 2. The information is combined together in step 1, 2 and 3. Basically, it's just mathematics with multiplications and additions, and then we get the emission factors in grams per kilometer per day. The total emissions are then multiplied with the length of each road segment and then we get the emissions in units grams per day or tons per year. So here is one more slide on the input data we need in the Tier 3 method. Vehicle category information in car fleet composition by vehicle categories, so passenger car, light commercial vehicles, buses, trucks without a trailer and trucks without a trailer. These are main categories, and in all these main categories we have subcategories for fuel type and Euro class. In Finland this information can be found in Lipasto, That's a database of Technical Research Center of Finland. And then we need information from the road and each road segment we want to study. That means the speed limits, a number of different types of vehicles on the road. And this information is also publicly available on these websites. This is one simple example of the emission calculations. One application of emission calculation studies would be to find out how much emissions one transport event causes. A truck with a trailer that uses diesel fuel and that engine is classified in Euro 4 class travels from St. Petersburg to Helsinki. So travel speed in average is 80 kilometers per hour in average in that section. Emission parameters for NOx is 6.1 grams per kilometer and the driving distance is approximately 320 kilometers. So then one transport causes almost 2,000 grams of NOx. However, if the truck was classified as Euro 6 class, the emission parameter of NOx would be then only 0.3 grams per kilometer. That's quite a lot less than for Euro 4 class engine. Then the transport event from St. Petersburg to Helsinki would cause only 93 grams of nitrogen oxide. In the project GreenInterTraffic, we did exercise where we want to calculate the emissions from Helsinki to St. Petersburg on the road E18. The input data is from the year 2018, and that means that we have the data of traffic fleet composition, traffic speed, number of different type of vehicles on the road from the year 2018. And in this picture you can see the number of vehicles per day in average on the road. The darker the color on the map on the road means the more vehicles on the road there are. And then we calculated the NOx emissions that caused by the road traffic for the road E18 from Helsinki to St. Petersburg. The calculations are done separately for small road segments, and we take this into account that the traffic composition varies on these segments. And we calculated also the particulate matter emissions caused by the road traffic on the road E18. The darker the color, the more emissions there are, and you can see the scales on the left side of the picture. So conclusions on the emission calculations. Now that the emission calculation methods are known, different kind of emissions can be made. Emission calculations can be made. For example, emission calculations of one single trip, and that would be probably quite interesting for transport companies. And the emission inventories for whole network to find out how much pollutants are emitted per year, or emission dispersion modeling based on the calculated emissions of the road to find out the concentrations of each pollutant in ambient air. And point 4 would be to calculate different kind of future scenarios and impact of the different emission reduction actions on total emissions. by changing the suppositions behind the calculations, like changing Euroclass distribution or share of different type of vehicles on the road, or even alternative road alignments, different type of scenarios can be tested and seen example what kind of impact these have on environment. Points 2, 3 and 4, I think they would be quite interesting for emission inventories, and to the air quality dispersion modeling results would be interesting for the authorities and for city planning purposes. So thank you for listening to the second part of the lecture. See you in the third one then quite soon.